Okay, so here is problem number 1, or A. The model shows one green rectangular tile and then 1, 2, 3, 4 yellow squares. If you look at the key on the top right-hand corner, it tells you that this is a positive x, and these are positive. They each represent 1, so a positive 1. When we write it, we show our x right here, and then we count our tiles and we say +4 because there's 4 positive squares. Then we have on the other side of our equal sign, you'll notice on the one that they have, it's like a little scale, and I put an equal sign on the bottom. On the other side, we have 11 if we counted them squares. So we just write 11. To write the equation for this model right here, it's x plus 4 equals 11. This is how you write the equation that represents this model right here. I guess if I move this up a little bit, it kind of shows you how that would go. So this is on one side of the equal sign, and then this is on the other side, just like this right here. Now we actually need to solve this one-step equation. What we do is we make what we call zero pairs. So I need to get rid of everything on the side except for my variable, which is this x right here. So I had 4 positive squares. Now I need to add 4 negative squares, which are the red squares, to zero out this right here. So if I have a positive 4 minus 4, that's going to equal 0. That only thing it leaves is my x. So because I put this up, let me put it up here so you can see. Whatever I do to one side, I have to do to the other side. So since I had 4 red squares here to zero out these yellow squares, I need 4 red squares on this side to zero out 4 of the yellow squares on this side. Again, zero pairs. Where you have a positive and a negative, they zero out. They make a 0. +1 minus 1 equals 0. So I have 11 minus 4, because I only had 4 red squares, gives me, it leaves me my x because I zeroed it out, which means it went away. It was able to get deleted. So now I have the x on that side. Again, let me move this up so you can kind of see it. And then I have 1, 2, 3, 4, 5, 6, 7 on this side. So when I write the equation, it's 7 equals x. That's my solution to this equation. Now, in order to understand if that is correct, I'm going to go back to this one, and I'm going to substitute that 7 in here, just to show you, because this was the original equation. 7 plus 4, does that equal 11? It actually does. It equals 11. So that means that when I solve for my x equals 7, right here, when I substitute that 7 or replace the x with 7, I know that this is correct, because 7 plus 4 does equal 11, which makes this statement true, which means I was able to solve for my x by going through, by making 0 pairs, or doing the inverse operation. We talked about what's happening here, what operation's happening, a positive 4 or +4. The inverse is subtract 4. What I do to one side, I do exactly to the other side. I'm subtracting 4 on that side. I'm showing here that x equals 7, and then I go back to the original equation, which was x plus 4 equals 7. I substitute my variable for the answer, and then I see if it's true. If it's true, then I know that x equals 7. If it's not true, then I made a mistake somewhere. I need to go back and I need to find the mistake. Okay, that's example A.